Thank you very much, and thank you for your presence tonight. So I'm here, yes, as Lev said, I'm here to compress my thesis in about 45 minutes. I'll try to make it not too boring and not too complicated. What happened is about 10 years ago already, 2008, I started thinking about the lab as a subject of study. And this main question, what is an architectural laboratory, started being the center of my attention. And it took me about 8 years to go through it, try to clear up what the history of the lab is, what it means, what it implies. But this question, what is an architectural laboratory, has been the main driver of my research for the past 10 years. So the best way to understand what a lab is to really to start with an overview of what's happening around us. It's a phenomenon that's obviously characterized by a significant growth in the last 25 years. When I started my thesis in 2008, there were about 80 labs. When I finished my thesis in 2016, there were about 140. So that's an increase of about 60%, which is a lot. If you look at the so what I did in the case of my thesis, I really did an inventory of entities in the field of architecture that are explicitly identified as laboratories. It was really one of the main elements I wanted to make sure. I wasn't interpreting things to be laboratories. I wanted people to say we have a laboratory and see if that would, what that would imply. So the first step that I did in my research was to really build a huge database of about 170 laboratories over pretty much 150 years, trying to figure out what they meant, what they were. So this is a part of the database, and this is a highlight of some of the elements. And you see that it's very different. There are very different elements. So you'd see something like visual design lab, for example, architecture lab, lab works architecture. So those words keep coming back: lab, architecture, design lab, media lab, theory lab, Bauhaus lab. It's like almost a buzzword, and it doesn't mean much. It looks like a bit of a fake way of presenting things that would make them hip. And when you go a bit closer and you start studying those elements, you see that, for example, some elements are going to be different. You'd have the ILAUD, for example, International Laboratory of Architecture and Urban Design, of which I'll speak a bit later, set up by Giancarlo De Carlo in 1976, which is really a pedagogical studio that went on for a few years. You'd have, for example, Archi Lab in French, cycle of conferences and exhibitions. So that's a completely different thing. It's not pedagogical, it's not a studio, it's really like exhibitions and conferences. And then you have Laboratory for Visionary Architecture, LAVA, which is a professional practice. So the idea of the lab is not something that's really limited in the field of architecture. It's pretty much everywhere. And what I did when I started studying my database is to start splitting it up in contexts. So I'd have the academic context, the professional context, and I also included the broadcasting context. Broadcasting meaning exhibitions, museums, magazines, etc. And what this shows is obviously that the academic context is where you find the most labs. But the labs are really present in all the contexts. So the big question, I'm going to start asking questions and try to see what exactly the lab is. So when did the idea of the architectural lab appear? Is there like a specific date? So I went from this idea of the last 25 years and went all the way back, and what you can see is that the idea of the lab is really an old one. It's an exponential growth first, so it's something that really, it's not growing steadily, it's growing exponentially. And it started really a long time ago. It's not a recent idea. So as you can see here, the idea of the lab appears in both academic context, professional context, and broadcasting context pretty much over the last 100 years. And it really appears, the first laboratories appear at the end of the 19th century. the first one, the really first one, the first lab that I could identify itself, is the architectural laboratory that was set up at MIT in the 1880s. There were 2 iterations of that lab. They didn't last long. It didn't really work, actually. It was just an idea that was just thrown there, and it didn't really pick up. But it's interesting that they tried twice over 20 years to make that work. The second major iteration of the lab, the second major happening of the lab, I'd say, is pretty much what Anna presented 2 weeks ago. It's all the Russian avant-garde movements that really related to the architectural lab and really took hold of this idea and started implementing it pretty much everywhere. So you'd have the laboratory period of Russian constructivism, you'd have Ginsburg's constructivism as a method of laboratory, and Ladovsky and the psychotechnical laboratory. So all of these I'm not going to go through. What I really want to stop on and really take a bit of time to explain, because it's really interesting, is the one that happens after that. In 1937, Frederick Kiesler set up a laboratory at Columbia University, and I really want to take a bit of time to explain that one, because it holds a lot of things that really help understand what a laboratory is. So who? Who is behind the architectural lab? Obviously, nobody is, and pretty much everybody is. In this case, we're going to look at Frederick Kiesler and see how he came up with that idea. If you're familiar a bit with Frederick Kiesler, he's usually known as an artist, architect. He's not a scientific person, usually. This is the way we see him. This is him working on a sculpture, in a sculpture also, in the 1960s. His most well-known project is the Endless House, which is quite a complex and hard to define space with interconnecting interiors. You see him here in 1959 with this model. And even the plans are really, they're not straight, they're not scientific. They don't look like something that's out of a lab. They look like something that's really artistic and really felt as a sculpture. So it's interesting that Kiesler worked about 20 years on that project. But most important for me is what he did in 1937 when he set up a laboratory at Columbia University, the Laboratory for Design Correlation. This laboratory didn't last long. It lasted about 5 years, and the last year he got financing from one of his students. The school actually cut the financing, so it was really the end. What he did in this laboratory is he did 2 projects. He had a very limited number of students. It was a pedagogical laboratory set up as a course. He had about 3 to 4 students every semester. And they worked on 2 projects mainly, the mobile home library between 1937 and 1939, and the vision machine between 1938 and 1942. But it's not the number of projects that's important, it's what they did with it. It's how they went about to design them, what they meant for the laboratory. So, in order to understand what the ideas behind Kiesler's laboratory, we have to go back to his understanding of architecture. So I'm just going to, I have to explain this very quickly, it won't be too long. For Kiesler, there was a major problem with architecture as it was made. He didn't like the idea of style. He didn't like the fact that we would go from a set of rules to another set of rules. And he found that there was something missing in architecture and had to be related to something else. And the way he visualized basically life in general, he produced this diagram in 1939 that pretty much explains it. It's not too complicated. Basically, he says that we go from, there's a constant change of needs. We go from one need to another because life changes and society changes, the world changes. And what's a standard at a specific time can't be valid later on. So we need to basically change our standards and adapt to life as it changes, and people either change and the body changes. And so he imagined this this cyclical way of functioning, where you go from old standards to present standards to new standards, and there's a continuous change over time. And that would take, actually, as you can see, a very long time. Just he identified 12 steps from the present standard to the new standard. And just the steps from 6 to 10 take about 30 years. So it's a very, very long process. But for him, this was the only way to, what he called, combat the perennial crisis in architecture, because it was completely jammed as a discipline. And he explained this in a major conference on design teaching in 1940, in which he says the Laboratory for Design Correlation that he set up has set itself the goal to define fundamental needs in life processes as well as design processes. Based on its experience, it has proposed 2 new disciplines to combat the perennial crisis in architecture, namely correalism, an investigation into the laws of the interrelationship of natural and man-made organisms, and biotechnique, which is the application of such knowledge to the specific field of housing man adequately. So basically, what that means is correalism is a science, and biotechnique is a method to combat the perennial crisis in architecture. And those 2 elements, correalism and biotechnique, are those 2 tools that he organizes his laboratory around those 2 ideas, and he builds them, basically. The laboratory is a way of constructing those 2 new tools of architecture. So what he did basically is invent a method. Like, how can you design architecture? If you can't rely on styles, if you can't rely on rules and the way things are thought, how can you build architecture? How can you design architecture? So he set up this metabolism chart, which is a huge diagram that explains the design process, and he published it. I have the image I'm presenting here is the one in French. It was published in 1939 in English in Architectural Record, and then he did the Correalism, Manifeste du Correalisme in 1949 in French, and that's the French version, but it's pretty much the same thing. So what needs to be understood, and it's really easy to understand, biotechnique is a design method for the production of a metabolic architecture. This is his main thing. We have to go back not to architecture, to styles, to artificial things. We have to go back to the human being, and the human being becomes the way architecture is validated or not. So I'm just going to explain this chart really quickly. I'm going to start from the end, because it's the end that really matters. Correalism is a means of conserving energy and generating increased productivity. Kiesler was, for Kiesler, man was like a battery. Basically, the human body is like a battery, and the more you use it, the more you create fatigue, and the body gets tired. If it's too tired, it dies. But if you don't stimulate it, by stimulating it, you kind of tap into unknown sources of energy that are hidden and we're not using. So the idea is to get just equilibrium between stimulating the body and not tiring it too much. So that's what he says here: conservation d'énergie, diminution de la fatigue, augmentation des stimulants. So augmenting stimulus and diminishing the fatigue of the body. And in order to do this, he acted on 3 different elements: function, form, and structure. And so he goes back to what architecture is, and he sees how everything is interrelated and has a direct impact on the body and the fatigue it creates in it. So it's a kind of a complex diagram table that you see here. But very simply, what it means that the architectural project, the object itself, is completely split into manipulable components. It's not a whole. It's a set of elements. And what he did, and this is a part of a database that I found in the Kiesler archives in Vienna. It was very organized, and they really built a way of organizing the information. So instead of thinking of the architecture as a whole, he says architecture is technical, aesthetic, physiotechnical, environmental, sociological, economic, and an object itself. And everything is then split into little pieces, and everything is split again in other pieces. So instead of tackling the whole project in a go, he tackles all the elements separately, and it goes so far as the book, for example, for the library, he would study the book it becomes an object of study, and for what you see here, might not be very clear, but his students and him go all the way back to what a book was in the Middle Ages, what it was for the Romans, the Egyptians, the Babylonians, how it was, what material it was made in, how it was protected, how it was bound, how it was stored, how much it cost. So everything is part of information that he builds. All the elements become a part of a huge set of database of information that will help understand how the building is, the project is designed. And obviously, he doesn't design because he wants things to be aesthetically pleasing. He wants them to reduce the efforts affecting the body. And this is the only criteria that he has. So if you look at the very right section of the diagram there, what he really wants is reducing all the efforts that are going to be applied on the body itself. So the mental effort, the visual effort, the manual effort, the torso effort, the pedestrian effort. We don't need to walk too much. We shouldn't concentrate too much. We shouldn't go up and go down too much. So these are all sets of constraints that will inform the project. So what he does for that, he comes up with diagrams like this, for example, the correlation chart of a book storing. So quite simply, you see that this is a body, and there's an ideal position for the books. They can be too high, they can be too low. There's an arc because the hand kind of turns. So he comes up with words. So there's like the knee shelves, the torso shelves, the head shelf, overhead, step shelf, top shelf, etc. And he invents new measurements, new terms, etc. But that's very theoretical because he needs to go further, right? He needs to understand what does it mean for the body to be tired. And in order to do this, and this is where it becomes really a lab, he completely split up the elements in little pieces. And then he tries to see how every element is going to have an impact on the body. So how do you measure fatigue? There are ways to do this. So this is part of a series of photostats that's also in the Kiesler archives. What Kiesler and his team did, they tried to figure out all the elements, all the ways, all the methods that were developed by scientists to measure the fatigue of the body. So this is one, muscular contraction and relaxation measurements, invented by University of Chicago and Bell Telephone Laboratories in 1928. The laboratory, Kiesler's laboratory is in 1937, so that's 12 years earlier. It's quite recent. There's more recent, 1935, the polyelectrophysiograph. That's a very new machine, and the archive really shows a whole series of letters that he exchanges with the people who invented and sell that product to try to figure out how to use it and if he could use this for his project. In all, he collects. He doesn't collect them physically in his laboratory, but he sets up a list of about 20 different ways of measuring the fatigue of the body. And he lists them, and everything is documented, everything is very specific, because it's his way to validate that architecture is going to be designed properly. So that's the list of all the elements. And they're very, very precisely defined. Everything is historically related to something else, very precise. But obviously, he doesn't know how to use that because he's an architect. Okay? So he needs to figure out how to do this. And in order to do so, he'll start inviting people at the laboratory. So what the Kiesler archive also has in stock is laboratory reports that he produced for the dean of the School of Architecture. He produced one every semester for the first 4 semesters, 2 years. And what's very interesting is that in the first 3, He lists every person that he invites precisely, specifically for the laboratory for their expertise. So what I did is I compiled all the names, and I tried to see where they come from, and which is really surprising because if you look at all the list, there are 2 people from architecture, the architectural field. All the others are from completely different fields. You have people from anatomy, anthropology, biophysics, chemistry, electrical engineering, genetics, neurology, physics, psychology, zoology, I mean, pretty much everything. And if you look at the lower part there, a lot of people working on materials, people who know how materials function, so really the industry. And the diagram that you see on the right is basically a list of a numbering of all the people he invited. So the first semester he has 10 people invited. On the second semester, 16, the third, 21, so it keeps on increasing. It's really ongoing and it builds up. What you need to know is he has about 4 students. So he has 4 students and 16 guests, 21 guests. It's really impressive. So a lot of expertise that comes inside the lab and try to help people to understand how the anatomy will work, how, really get the information from out there. So basically setting up a collaborative and multidisciplinary working with these people. But what he does is even better. When you start comparing before going further, what's also really interesting, it's that what you see in blue is the people coming from academia. So at the beginning, it's all academics. But the second semester and the third semester, there's an increase of professional people coming from the industry, from the professional practice. So he starts really opening up the academic field to people from outside and trying to get their expertise in. And what I did after that is try to compare, see how many people are recurrently coming, how many people are going to come back semester after semester. And it's really fascinating because obviously the first year there's nobody, but at the beginning there's 2, and then there's 17. So basically, out of the 21 on the third semester, 17 were people who were already there. So he starts basically building a transdisciplinary network. He starts getting those contacts in place. He invites them, he talks to them. And the way he explains it in his documents, it's not just that we as architects need their expertise, it's also that us as architects, can teach them stuff about their own work. So it's a two-way exchange that he proposes. So this quick study that I presented of Kiesler's laboratory kind of helped me to answering this question: how is the architectural lab structured? How do you structure a lab? And it took me, enabled me to propose those 3 distinctive features. A laboratory can be seen as a set of operational instruments, like he has, the machine that he's using. The application of a structured method, which is the biotechnique in his case, and a flows of social exchanges, which is what he sets up with his network of exchanges with people coming in and coming out of the laboratory. So I'm just going to go through this really quickly because I want to get to the later part, which is more interesting. But obviously, not all the laboratories are as complete as Kiesler's. Kiesler is really strong on all 3 fields. Some are going to be stronger on one axis, some on another. So for example, if we look at the architectural laboratory as a set of operational instruments, some of the laboratories that I discussed earlier are really structured that way. The laboratory at MIT is really completely focused on material, on the instruments. How do you use the instruments to test architecture, etc. Ladovsky's laboratory, the one that Anna presented 2 weeks ago, is really the same thing. It's all about designing instruments to measure architecture. There are others that came later. Maybe the most interesting one would be the Architecture Machine Group by Nicolas Negroponte. So I'm just going to go through them, but what's interesting is that those ideas of a set of operational instruments completely directly relate to what you see in green there is what we call the digital turn in architecture that would start with AutoCAD in 1982 and ends pretty much, it's not over because now we're doing something else, but it ends with the BIM in 2009. So all of these are new instruments. We're not using tools that are instruments that we use by hands. Now they're machine tools. So a few examples really quickly. The Laboratoire d'Expérimentation Architecturale was set up in 1976 by Pierre von Meis in Switzerland. And this was completely organized around the fact that they had platforms, the mobile platforms. They could move stuff, they could build stuff with the machines, and they could build prototypes. And we have more advanced versions of this today with the robots, etc. So we go from analogical tools to digital machines, as I said. And you have on the right here the architecture machine drawn by Nicolas Negroponte, which is the result of the symbiotic dialogue between the architect and the machine. And this happens, he thinks about this in 1969. And this is when he sets up the architecture machine group, which will become the media lab afterwards in the School of Architecture at MIT. So those are really, labs are focused on tools. They're not only machines, they're also computers, turns into something else. If we look at the application of a structure method, the architectural laboratory really organizes the application of a structure method. This brings us back to, for example, in the case of Ginsburg, it would be the constructivism as a method of laboratory, which is a complete method of designing architecture. It's all a method. There's no space, there's no machines, there's nothing, just a way of thinking about architecture, and he calls it a method of laboratory. And this at this point, what I highlighted here is all the research that was done on design methods in the 60s and 70s, sorry, where researchers were trying to figure out how design could be automated, basically. What were the method? How could you create an algorithm to design architecture? So I'm not going to go through this, but you see here a few suggestions that were presented, advanced by Geoffrey Broadbent, and another lab in France that really works on these questions since the 1970s, really. But the one I really want to focus on tonight is the third one, which is, I think, is the most interesting one for the new transformations of the laboratory today. It's the one about the architectural laboratory as flows of social exchanges. Because in the end, the question that relates to this is, where is the architectural laboratory located? And this is a question that's completely different from the others. Because if you remember that picture that Evangelos showed a month ago about, that I had actually spotted in my thesis, and I kind of obsessed over it because it's quite pretty also. But what's really interesting is you can actually see everything. You have the machines, you have the instruments, you have some kind of method. You see that the doctor is using a specific way of probably touching things. And you have people around him looking at the way he works and trying to get the information out. And the way this picture shows the laboratory, it really, it's like a cocoon. It's closed, it's controlled, and a laboratory is usually a controlled environment. It's not open to the outside, it's closed to the outside. And Bruno Latour did a lot of research on the walls of the laboratory, how porous they are, etc. And that's what's most interesting in this case. If we look at the idea of social exchanges and the ones that we would see between the doctor inside and the cameraman outside, the people looking, the people taking notes, etc. So there's like an exchange of information that goes through the wall of the laboratory. It brings us back to, and this is where I think the future of the laboratory, the present actually of the laboratory is. I relate it directly to the idea of the network. So maybe through a few examples, things are going to be clearer. The first example that I want to show is the iLoud that I talked about quickly a bit earlier on in 1976, set up by Giancarlo De Carlo. So what's interesting about this is that Giancarlo De Carlo really took the idea of the ideas of participation and collaboration in architecture. And we see him here at the Milan Triennale. We see him also with Team 10 and Aldo van Eyck's garden. And everything was about creating groups, working together, exchanging, doing something together, not doing something alone. And he takes this idea and he sets up the, so this idea is really close, to, in the 70s, is really close to what Peter Gallison and Caroline Jones highlight in their study of the places of production, when they show that before 1945, in science and art, work is usually done in solitary and isolated environments. Between 1945 and 1970, we start seeing centralized collaborative work, and that would be the equivalent of those garden meetings, Team 10, etc. And after 70, we start seeing decentralized collaborative work, and that's the appearance of the network. And if I go back to the drawing that I was, of the diagram that I showed you here, that's exactly when the ARPANET, the first computer network, appears, the pre-internet, basically. So we're really into this idea of starting communicating, not living in isolated spaces and pockets, but really reconnecting people to each other and working together. And what Giancarlo De Carlo does is exactly that. He goes from the idea of a summer studio in Urbino with students from different schools, different universities all over the world. And he grows frustrated in 1980 because he says you can't do research over just a summer. You need to work longer, right? So what he suggests is to, he produces this document that was presented here at the Other Architect exhibition a few months ago, years ago now. And he organizes the work between all the different universities and schools. And he says, for example, the MIT is going to work on tractability. Italy is going to work on types. Barcelona is going to work on the pastiche. Zagreb is going to work on communication. And we're all going to work together. And everybody's going to take a part of the problem and work on it. And then together, when we get together in those studios, we will share our information, share our knowledge. So that drawing is really clear to me. Is the first real architectural network that's set up in a very clear way. And it's a laboratory. So basically the iLoud is not people meeting in summer. It's a network that's completely decentralized, that exists nowhere. It exists everywhere and nowhere at the same time. Another example that's really fascinating is that I mentioned a bit earlier also, Laboratory for Visionary Architecture, LAVA, that you see over there in 2007. This one kind of opens up another door. So LAVA is a professional practice. They produce architecture. It's been founded in 2007 by three young architects, Chris Boss, Tobias Walliser, and Alexander Rieck in Stuttgart and Sydney. So that's quite interesting in per se. When they talk about the way they have a little text on their website which presents the way they work. And the words that they use is, for example, at the vanguard of a nonconformist and inventive new generation, we have to be forward-thinking. There's really this approach, this way of being very experimental and their way of designing architecture and project into the future. And the way they produced a little book also, when you look at the title, it's called Tomorrow Never Dies. It's very, again, very science fiction approach, very looking forward. But what's really interesting is that there's something more. It's not just projecting into the future, it's also thinking for the future, because they say very clearly, LAVA operates as a unique think tank with branches placed strategically worldwide. So it's also research. It's not just producing objects, it's also doing research. And that's really interesting because it's not something that you see every day. On their website also, So this idea of having branches a bit everywhere in the world, the fact that there are 3 directors. One director is set in Sydney, the other one is set in Stuttgart, and I'll talk about the third one a bit later on, you'll see why. So they have different nodes, different poles. It's a bipolar agency. It's not a centralized network. There's an internal network in the office, and there's also an external network with their clients and their engineers, etc. You see the network is over there with the engineers and all. On their website, they also had a map. I don't know if you see, yes, it's kind of clear. So they have a world map of their networks, and what's really fascinating about this one is that if you look very closely, you see all the poles, you see all the nodes, but you see also the lines, the curves that go from one to another. And if you look really closely, they have 2 sets of colors. They're not the same color. There's green and there's blue. So green is site visit, workshop, presentation, launch. And blue is collaboration, technology, research. So they have not one network, they have 2 networks. There's a design network and a research network, and they do both. So it's really a firm that plays at the same time in research and design. And that third director that I was talking about that I didn't mention, Alexander Rieck, what's interesting about him is he's also, so he basically is a co-founder and a co-director of the office, but he's also a senior researcher for the Fraunhofer Institute, which is one of the biggest applied research centers in the world, in Europe. It's in Europe and in the world. It employs tens of thousands of people. And what LAVA does, so they're working with this researcher, an actual researcher who does research, who publishes papers, scientific papers, gets grants. There's a lot of exchanges. So what they do is they work in 2 parts. Either they take the scientific research that he does, for example, in this case, and they produce design based on the findings of the scientific research, or on the other side, they act as designers that are part of a scientific research team. So they really play on design and research, thinking and making at the same time. Which takes me to the, so what we have here, ILIDE was very organized around academia, doing research and project, both for school, pedagogical. And here we have a professional practice that also does research, but also with academia. So there's like two sides to it. And that brings me to the last case that I wanted to show you, which is the laboratories of the JSAP. The Graduate School of Architecture, Planning and Preservation of Columbia University. So what's fascinating with them is that in 2002 they started building laboratories, and in 2012 when I was doing my research, they had 30 labs. That's a lot. So they had 30 labs in one single environment, and we can pretty much talk about lab culture at this point. If we look at the timeline of when those labs were set up, between 2002 and 2012, everything appeared. So those almost 30, because they have a few that were planned but never happened. So over 10 years, they set up 30 labs. That's 3 per year. It's really quick. So in order to understand what it meant, what those labs were exactly, because is it just like buzzwords, just names? Is it stuff that, I mean, just labels that we put on entities just to, be hip again or pretend that something's happening? I looked at what they produced. Basically, if it's a lab, if it's an entity, it does something. So let's see what it produces, and that would help me better understand, what it does. And what I did is I split, taking again the same separation between thinking and making, research and producing, designing. Sorry. I did a distinction between producing explicit knowledge through publications, so writing, and recognizable objects through projects, so basically designing projects. Are you either doing a project or writing a paper, producing knowledge? And when you look at the results of this study, this is what you get. You get 30% of the labs produce only publications, so only scientific research. 20% only did projects. So there's no writing or hardly any writing. It's all about everything is embedded in the project itself. 13 did both, and 37 did nothing. So 37% of the labs did absolutely nothing. They had no production, there was nothing. And this would tell you that obviously it's a buzzword, it's nothing, right? And when you look at the detail of what's those 37%, you guessed it, they're most interesting actually, because those labs are the Studio X Global Initiative, and they don't produce anything. And the first one is X Radio, which is a student radio, but this doesn't count. It's still labeled as a laboratory in Columbia, at Columbia. So this brings me to the Studio X Global Initiative. What is that? Why would you have something that's called a lab, has no machines, no method, doesn't produce anything? What happens in there? So, Studio X Global Network. This was set up by Mark Wigley, the dean of Columbia at the time, in 2008. Started a bit later, not as soon as the other. And if you go back to the study that I did, you see that those who produced absolutely nothing really appeared much later. This is chronological, and everything starts appearing in 2008 and after. So this international network of nothing is basically nodes set up in New York, Rio, Istanbul, Amman, etc., and in different places. And there's also a book that says, well, this is like a report that says how things work. So the Studio X New York Guide to Liberating New Forms of Conversation. So it's all about conversation, it's not about producing stuff. So in this book, they show, for example, that the Studio X New York, the one in New York, is a space that could be changed to accommodate storytelling launch party, conversations with the architect, room opening, reading rooms, etc. A lot of things. So there's a flexibility to this space which can become pretty much anything. And they say very clearly in there, Studio X New York is not just an event space, it's also a working studio. So it's an event space where things happen, but it's also a working studio. And here is how to transform a workspace into an event space in 30 minutes. So it's very flexible, very rapid to change, very open. And it ends with those, it's quite a little book, very cute. And they have a lot of pictograms that says, for example, artist talk would be number one, panels, crate, etc. So there's different ways of arranging the room in order to accommodate different operations. The most interesting part of this book is obviously the statement of the dean, Mark Wigley, which ends the book. And he explains basically why Studio X is out there and what does it do. So I'm just going to read this, it's important. So the vision of the Studio X Global Network is to establish a unique exchange of ideas and people. The aim of this exchange is a global partnership able to offer support to the highest possible level of reflection on the new realities and the highest possible level of reflection on the new realities and active, intelligent, and productive engagement with those realities. So it's at the same time a space of reflection and a space of production. Each Studio X acts as an open platform for collaborative research and debate with a publication gallery, an exhibition gallery, etc. During the day, the Studio X is an active workshop with combinations of ever-shifting teams of local experts and visitors from the region or globe working on designs, reports, exhibition, etc. During the evening, the Studio X acts as a hub of social exchange and intense debate with a lively program of exhibitions and events. So we have two programs. We have, again, thinking about stuff and making stuff. So producing knowledge and producing objects. The thing is, the studio itself doesn't do anything. It's just an open canvas that enables people to work there and do this. And it's all about the communication at this point. With the addition of each hub in the network, this radical experiment in redefining the role, responsibility, and capacity of globally collaborative modes of education, research, and action increases its bandwidth exponentially, a new kind of collective brain is emerging. So those 37% of nothing actually have more impact than the labs that are working independently on specific projects, be them research or projects. And it's a collective intelligence bridging the gap between discipline and profession, because it's not only people from academia who are there, it's open to the people who come from the professional practices and interfere with the others. So why a lab? Why do architects need labs? Ever since I started my thesis, there was this obsession with this quote from Peter Gallison that says, you can't really define a lab. So it was kind of productive because I'm trying to define it and see what it means, but you have Peter Gallison, which is an expert on the field, and who says you can't really give it a single definition because it changes over time, nonstop. But what's interesting about the lab, and that's what he says, you have to see it as a site that reflects the broader culture in which it is embedded. He calls it the laboratory as mirror, and a guiding model of how its users imagine the world they want to bring into existence. Basically, the laboratory as blueprint. And this image works really well for the architectural lab, because if we go back to this drawing from this diagram that Frederick Kiesler proposed, the architectural lab appears as basically something that a tool, a device that will enable us to think about the problem. So that's the laboratory as mirror. We're thinking in the disciplinary way about the problem of today, of architecture. At the same time, it enables us to make something that will fix the problem, create a new standard, propose a solution. That's a laboratory as blueprint. And by doing thinking and making at the same time, it makes us completely disciplined and professional. It's not about separating the two anymore. It's about bringing everything together. So the bridge, basically the architectural laboratory is a huge bridge. It's a hybrid research device that enables us to solve problems, disciplinary problems. So, in conclusion, what is an architectural laboratory? At this point, we have enough information to propose a definition. I don't know if you have enough time left. Quickly. Maybe I won't read everything, but I'll just go through it. The architectural laboratory is a research device situated at the intersection of disciplinary and professional stakes. This is my proposal of a definition of the laboratory. And its appearance, the fact that it happens, the fact that it emerges as a phenomenon, echoes the transformations of both theory and practice, be they minor superficial crisis or major paradigm shifts. Because every time you have a laboratory that appears, it's an answer to a crisis. It's an answer to a problem, to a standard that doesn't work anymore. And we need something to bring us forward. And this is every time that if you look at the laboratories, they're usually the result of a reaction to some kind of crisis. So it's also, at the same time, a physical space defined by its enclosing walls, basically the machines and the rooms, etc. It's also a set of practices that go beyond these walls. And the architectural laboratory is organized, as I said, around three main components: the instrument, the methods, and the social structures. And this tripolar structure enables the various practices of experimental research, and experimental research that will produce two kind of results, basically unique architectural objects, and at the same time transmissible scientific knowledge, so research and things. So I'll just close with this. When is the age of the laboratory? I started with when did it start? When is it? Is there an age of the laboratory? And we were discussing this a bit earlier with Enrique. It's really interesting that in 2012 we had 30 labs in a single environment. We had a culture of laboratories. In 2016, when I was finishing my thesis, I had to go back and just finalize my information. And I couldn't find them anymore. They were gone, because now we have, in 2016, we had 7 Studio X's and 6 laboratories. And the words that are used are not as much laboratories, but we're talking about incubators, environments. So I'm not sure the laboratory is dead yet, but I think there's a new wave other ways of identifying those environments of research and exchange that are starting to appear. What I found most interesting is that if we go back to the way the exhibition is set up, it talks about the relationship between science and architecture. What I see is that the new transformations of the laboratory are not about science anymore. I mean, they're not about science and architecture. They're about communication and architecture. They're going beyond the fact that we're doing architecture in a scientific way. It's all about communication now. That's it. Thank you.
Thank you. That was really great. It brings back memories of when I was part of the C Lab at Studio X. One thing that should be noted about those labs are at 180 Varick Street, a couple floors above the OMA offices as well. So it was like kind of like a building that it was a hub of architectural activity as well. So I spent way too much time there. So it's like, it's really interesting because the successes of the Studio X system are kind of dubious. It's like I don't know what they did. So it's kind of I love seeing that being the topic of the presentation. Hi. So I'm Enrique. Hello from New York. I'm an architectural historian. Really good to be here. I was a visiting scholar here back in 2011, and I was amongst a really nice class. It was myself, Daniel Tolesnik, Michelangelo Sabatino, Andre Tavares, and the late Diego Seixas Lopes, which was a really nice group, and I have very fond memories of that summer. And it is the summer where I wrote my chapter on my dissertation on Etienne Joumaret's aeronautical experiments, which is part of the Vangelos's exhibit here. So my talk is called The Laboratory Outside the Laboratory. And for this talk, I want to delve briefly into a series of episodes, some culled from the history of architecture, some not, all organized around laboratories, all presented as being somehow connected. And more than anything else, I will be asking questions. I don't pretend to have answers. And my goal is not to be comprehensive, but rather to be interpretative, perhaps imaginative. I will begin with some remarks about how the space of the laboratory yearns to be outside, and from there I will move to a brief consideration of how the architectural student becomes a kind of instrument for the testing of ideas. The implication being, of course, that the studio can be a bit of a laboratory, as the previous presentation has just shown. And after that, in keeping with the theme of architectural education as a kind of laboratory environment, I'll look at the materials implicating the laboratory's shift from inside to outside. And lastly, I'll end with some general remarks about the contemporary ramifications of this weird notion of the laboratory outside the laboratory. So first, what do I mean when I say that the space of the laboratory yearns to be outside? In reality, this begs another question, which is this: what is meant by the strange title that graces this talk of mine, this idea of a lab outside of a lab? And the short answer is that I want to talk to you first about the physical and cerebral act of moving from inside to outside, about how the space that preoccupies this wonderful exhibit, the laboratory, makes a physical transition from indoors to outdoors. A laboratory is, after all, an architecture of confinement and confined space. It can be dark or illuminated, its ceilings, walls, surfaces, and corners flaring with the viridescent glow of cathode ray tubes or ambient blues from LCD screens. Before that, it was a space of candlelight, then incandescence, and then fluorescence. The laboratory could be teeming with strange instruments like the Bunsen burner, the Schlenk flask, the Berzelius sphere, whose names melded non-human actors with an all-too-human inventor. And speaking of spheres, here I should mention the vacuum sphere, invented by Otto von Guericke in 1654, which is not known as the Guericke sphere, but rather as the Magdeburg sphere. It seems a fitting place to begin, does it not? For as this engraving by Karl Schott shows, the halves of the Magdeburg sphere appear to hover in equipoise over the buildings and landscapes nestled along the Elbe River. Schott's engraving gives the Magdeburg sphere a kind of architectural urgency. The sphere is drawn. It appears pinned to the air above as the buildings are moored to the ground below. Yet something about the sphere appears not quite right. It is disassembled, floating, incomplete, aloft. And indeed, I began with this brief evocation of the Magdeburg sphere as a prelude to the architectural consequences of a laboratory that is similarly unmoored, that seems to exist beyond its normative architectural confines, which is to say the laboratory outside the laboratory that moves from indoors out and to the world at large. So when I speak of the way in which the laboratory moves from the inside out, this begs another question, one with more direct architectural consequences and ramifications. Does the laboratory have to cross some kind of threshold as it moves from its inner confines to the world outside? Is this transition physical? Is it metaphorical? Is it political? A bit of a warning as to my approach. When considering this kind of issue and when considering the architectural ramifications of the laboratory in this light, my first impulse is not to look at buildings and spaces, but to literature. So here's one example by way of a story. It's 1707, and Lemuel Gulliver, a surgeon pressed into service above the Cornish sloop Hopewell, finds himself marooned on an island after an attack by pirates somewhere in the North Pacific Ocean. Fatigued and hungry, the titular hero of Jonathan Swift's Gulliver's Travels then fashions a small canoe and paddles between nearby islands, searching for help and food. He arrives at a sheltered cove and spends a night in a cave, observing and recording the weather when he spots, quote, "a vast opaque body between me and the sun." In short, an island in the air inhabited by men. This is the flying island of Laputa, and as otherworldly as it may have seemed to Gulliver's discerning eye, this flying architectural object is of interest because its progressive motion appears in the novel in the form of an engraved map with corresponding lines tracing its flight across the water. Once aboard the island, Gulliver is given special permission to visit the Laputans, who have built their own cave in the middle of the island and made it a laboratory filled with, quote, "with great variety of sextants, quadrants, telescopes, astrolabes, and other astronomical instruments." This cave, perhaps the most architecturally complex space in Gulliver's Travels, holds the flying island's helm, a, quote, lodestone of prodigious size, its shape resembling a weaver's shuttle. It's a device that limits the island's flight to a series of oblique movements in the air, yet was nevertheless a product of a people, quote, perpetually conversant in lines and figures. Swift here is talking about people who draw, right? People who are in a studio. And when I think of a space that is perpetually conversant in lines and figures, I immediately think of an architecture school, one where teachers and students engage in that business of conjuring forms, shapes, and volumes, all woven from piebald washes, deft pencils, and lines of varying weight. It all speaks of confinement, yet there are plenty of examples that demonstrate how architectural education was not. I think of the fabled grand tours where artists and designers lit off for points throughout the Mediterranean to look at ruins from Roman and Greek antiquity. These sometimes ended in confinement. I remind you of the strange fate of Antoine Babetty Desgodet, who traveled to Rome in 1674 to make measured drawings of ruins and buildings from antiquity. His experiences as an architectural traveler are, for lack of a better word, remarkable. During his trip to Rome, Ottoman pirates captured and overran his ship. He and his companion, Jacob Spon and Augustin Chardalvier, were imprisoned in Algiers and Tunis and subjected to hard labor for a year. And Jean-Baptiste Colbert, the Minister of Finance under Louis XIV, and the tireless advocate of building up the French merchant fleet for an armada, arranged for the prisoner exchange. So once Desgaudet returned to Rome, he began the series of drawings that would become part of the influential book whose frontispiece you see here, The Ancient Buildings of Rome, accurately measured and delineated from prison, I should say, from 1682. Which is a way of saying that education could be both dangerous and risky in the early modern era. And it seems a far cry from today, does it not? Because we are all familiar with the culture of traveling advanced studios, where professors take students to places throughout the world to look at signature buildings and projects, all for the express purpose of shaping the mind of the young designer. Yet the architecture studio, like a laboratory, can be an insular space where research and intellection is somehow sealed hermetically from the outside world. Just ask people who took studio with Peter Eisenman at Yale. For some insight on this matter, let us again consult literary fiction, specifically the moment from Mary Shelley's Frankenstein or the modern Prometheus, when Victor Frankenstein visits his laboratory after creating his monster and finds him lying on the floor, half alive. Frankenstein is in horror at his own work. I paused to collect myself, he remembers. With trembling hand, I conveyed the instruments out of the room, but I reflected that I ought not to leave the relics of my work to excite the horror and suspicion of the peasants. And I accordingly put them into a basket with a great quantity of stones, and laying them up, determined to throw them up into the sea that very night. And in the meantime, I sat upon the bench, employed in cleaning and arranging my chemical apparatus. In short, the laboratory inspires escape to the outside, as if its internal workings are a bit of a pressure cooker. And if our metaphor holds correctly, the inhabitants need release. I wonder then if my own colleagues who survived architectural school viewed their own confined studio space in a similar manner, as if they too were trying to secret themselves away from school into professional practice as early as possible. I point out that Victor Frankenstein left the space of the laboratory with his scientific instruments. And here too, I wonder if some kind of architectural analog can be made. I suppose that my first impulse is to think of the tools of architectural education and practice. Compasses, may lines, straight edges, sheets of zipatone, clay-hued Borco, sticky to the touch, rainbow assortments of rapidographs and microns, laptops, 3D printers, KUKA, 5-axis robots, all as the equivalent of instruments and of drawings and renderings and models as a result of experiments. But could it be that the architecture student, that becomes a kind of instrument, someone on which architectural pedagogy leverages its aspirations and agendas? It seems strange, does it not? But let me again resort to other scientific and literary examples before moving on to an architectural analog. The English physician John Elliotson, an early advocate of acupuncture treatment techniques, was also known as one of the most outspoken promoters of mesmerism in England. So he often viewed his patients as diagnostic instruments for understanding the effects of physical and physiological influences on diseases, and would have public demonstrations of his hypnosis techniques. He was so famous that Wilkie Collins, in a crucial scene from his 1868 novel, The Moonstone, introduces a doctor modeled on Elliotson who subjects a suspect to a hypnotic trance and conjures a confession regarding the theft of the novel's titular jewel. And if we're looking to an analog, architectural analog to Elliotson's approach, consider Clem Peckover, the young protagonist of George Gissing's 1889 novel, The Netherworld. She lives with her mother in a London slum, a life that, as Gissing describes, quote, passes through the basest conditions of modern life. Life in the slums has registered in Clem a fiery appearance. As Gissing writes, quote, reddened by the rays of fire, her features had a splendid savagery that seemed strangely at discord with the paltry surroundings amid which she sat. Though Clem may be suffused with a burning desire to escape her situation, to leave her hovel and live outside among the landed gentry, Gissing describes Clem as a caryatid, one literally shouldering the burdens of urban life. Forged from the anvil of modernity, she has transformed into architecture, all for the purpose of testing an idea about modern urban life. There are examples, of course, in the history of architectural pedagogy where the student designer has become a kind of test subject. But to what end? At the Bauhaus, for example, Johannes Itten established the well-known Vorkurs, where a basic course of Vorlehre consisted of the study of form paired with workshop instruction, and this led to more advanced courses in formal and material techniques. And though the appearance of building in the center suggests the centrality of architecture in the Bauhaus program, I point out that it was not until Walter Gropius departed in 1927 that he actually instituted a more formal architectural department. Much remains to be said, however, as to how the Bauhaus pupil was not unlike Elliottson's mesmeric patient, which is to say, a kind of study or template for experimentation. As we know, Itten taught students principles of color theory while advocating a garlic-based macrobiotic diet inspired by Mazdaznan religious principles. The healthy body was to be developed along with the healthy mind. And we know that Gropius reacted strongly to this and abandoned Itten's mystic leanings in service of something more in line with contemporary concerns. Gropius, of course, modified the school's pedagogical agenda, including economic factors and links with industry, more on this momentarily, all into courses that investigated the potential for the mass production of chief products. As my colleague Dara Kiesler and others have shown, it was Hannes Meyer, however, who introduced a much more process-oriented methodology to Bauhaus instruction after Gropius's departure. This radical change brought by this new presence is discernible in Meyer's organizational diagram, where the four cores is literally broken apart, dissected, bureaucratized, and now features courses such as space acoustics, physics, chemistry, anatomy, and psychotechnics as a way of educating the pupil in science as well as in design. The desire to analyze and by implication to instrumentalize human activity outside the confines of the architectural school is evident in Edmund Kuhlein's diagram of a study for the periodization of living space. Drawn during the winter semester of 1928-29 from Meyer's Architecture and Interior Design Department, this diagram categorizes 7 inhabitants of a house in decile according to their gender, age, occupation, and familial relation. This diagram also maps out their daily activity, including eating, sleeping, even a visit to a zoo. It exemplifies, as Hannes Meyer observed in 1928, how building, quote, is a system of organizing life that clarifies physical, psychical, material, and economic concerns. It is a clear link to this laboratory mentality, but an even clearer one to Meyer's interest in incorporating ideals from the Vienna Circle into Bauhaus pedagogy. This is especially evident during the 1928-29 semester when Meyer invited philosophers Rudolf Carnap and Herbert Feigl to Dessau. They lectured Bauhaus students about diverse topics such as, quote, science and life, the logical structure of the world, and the four-dimensional world of modern physics. In short, Meyer's approach incorporates elements from the behavioral and natural sciences, rarefies it as an architectural curriculum where a kind of alembic for distilling ideas and then channels them outward into the world at large. And this laboratory mentality implicated more than just students, for in some ways, the materials and instruments of the architecture school were what enabled this transition outside. The Bauhaus traveling shows, their active publication culture, and even Meyer's Red Bauhaus brigades are important when considering how this laboratory mindset kind of migrated from the Bauhaus to the world outside. There are analogous vectors of transmission, however. One that deserves special attention occurs after the end of the First World War. So the 1922 Treaty of Rapallo, which ended hostilities between Germany and Russia, stipulated for the exchange of industrial and manufacturing patents between the two countries. And as part of this arrangement, German companies like Junkers assigned patents to Russian manufacturers. The famous corrugated metal wings and airfoils developed by Hugo Junkers at Aachen in 1929 were now manufactured at a Junkers factory at Fili outside of Moscow. Soviet design bureaus such as Andrei Tupolev's incorporated these techniques and manufactured large aircraft with corrugated metal skins. Junkers, it bears mentioning, is an important point of contact for the Dessau Bauhaus, and not just because of its physical proximity. In 1930, technicians and designers at Junkers experimented with prefabricated metal housing prototypes. And earlier, however, the points of contact between the Bauhaus and the Junkers were more fortuitous. I wonder, and I would have to ask my former teacher, Spiros Papapetros, if Siegfried Ebeling based his own ecological view of space as membrane, Raum als Membran, on Hugo Junkers' corrugated metal surfaces for airplanes. These are, after all, surfaces with spatial ramifications because they're both structure and envelope at the same time. Ebeling, as we also know, was an airplane fanatic. So these connections to aircraft testing and design continue. As I mentioned, the Junkers factory at Dessau developed prototype housing made of metal using techniques culled from aircraft production. And at the Dessau-Torten escape, the painter Georg Mucha and Richard Paulik, they developed their own experimental metal house that was easily demountable and featured flexible floor plans. And Marcel Breuer was initially supposed to work on this project, and Breuer developed his own interest in bent metal furniture after visiting the Junkers factory. He eventually assigned his patents for bent steel furniture making processes to companies like Thonet, Desta, and Standard Mobile, who all created their own line of rigid, lightweight chairs for use inside airline passenger cabins. These examples suggest how the architectural space of the laboratory migrated outwards through various methods, from the use of instruments to the instrumentalization of pupils, and finally through the development of techniques that could be deployed out in the world. And this all assumes that it was done for higher purposes. But there are instances when this idealistic view of the architecture studio as a kind of a laboratory out in the world takes on a darker aspect. During 1943, for example, the technical division of the US Army's Chemical Warfare Service enlisted Erich Mendelsohn, Konrad Wachsmann, and Antonin Raymond to aid in the, quote, design and construction of typical German and Japanese test structures at Dugway Proving Ground, Utah, all for the purpose of testing new napalm-based incendiary bombs. Mendelssohn was brought on board as an expert in German housing and factory construction. Based on his work in books like Hochhausbau, Technik und Gestaltung from 1930, Wachsmann was appointed as an advisor on wood construction techniques. Similarly, Antonin Raymond, who worked previously with Cass Gilbert and more famously with Frank Lloyd Wright in Japan, advised the Chemical Warfare Service on Japanese wood construction methods. Though each architect worked from the confines of their own offices, their designs were built and tested at the Chemical Warfare Service's experimental facility at Dugway Proving Ground in the middle of the Utah desert. The research was methodical. Douglas fir and other kinds of woods were used to replicate Northern European woods. used for framing. Hinoki and other kinds of pine were flown in from Hawaii to simulate Japanese timbering. The structures were built, bombed, rebuilt, rebombed, all with the express purpose of generating data on the burn rate of German and Japanese housing and factories. Now, I mentioned Mendelssohn, Waxman, and Raymond, not because I seek a kind of moral equivalency to architecture practices of today, but rather for the idea that the architecture here is treated as a kind of technical expert whose designs are tested in a laboratory-like environment, and it just happens that that laboratory is out in the field and it's done for an expressly military purpose. This is a defining aspect of modernism, of being modern, or architectural modernism. And it's perhaps encapsulated also in this image of Le Corbusier testing one of his murs neutralisants, or sealed glass partitions that created thermal envelopes, all envisioned as part of the Centro-Soyuz project in Moscow. And there is, of course, Le Corbusier's collaboration with Gustave Lyon, the acoustics expert. Together, they worked on the design for the massive auditorium that was to be part of the failed Palace of the Soviets scheme. These projects all involved off-site design and testing. Now, this notion of collaboration between architects and scientists in a laboratory brings to mind historian of science Peter Gallison's notion of the trading zone, commenting on the space of the laboratory as a space where theory and experimentation, or science and technology, may seem incommensurate with each other. He notes, quote, "But instead of looking at laboratories simply as the places at which experimental information and strategies are generated, my concern is with the site, partly symbolic and partly spatial, at which the local coordination between belief, which could mean theory, and action or experimentation take place." Now, this is useful stuff, especially as it may point to how some design practices portray their work as interdisciplinary, and the studio a space of negotiation and exchange with techniques and processes from other professions. Yet, I take issue with Gallison's formulation of the trading zone, if only for the fact that by their very nature, contemporary architectural practices already embrace this type of coordination that he so methodically kind of picks out. And speaking as an architectural historian, we already have to negotiate this room as well. After all, we often celebrate counterfactual history, the what if, when we investigate unbuilt schemes by architects and designers, as if this kind of work provides some kind of insight into the aesthetic, social, and political realms that no built work can. So the question remains as to whether the laboratory method is even valid. Benjamin Ball and Gaston Nogues of Ball and Nogues Studio in Los Angeles, for example, used their studio to actively investigate the shared domains between art, architecture, and industrial design, a true trading zone. But then again, designers like Ball and Nogues already claim that their work, though the product of a laboratory-like environment, is different. In a 2017 interview, Benjamin Ball claimed, quote, "Our studio isn't an academic materials laboratory. We aren't developing techniques and methods and then writing about them and presenting about them in conferences. The stakes are different for us. We are trying to bring programmatic, cultural, and aesthetic meanings into the project rather than isolating processes, techniques, and form and viewing it in a vitrine. We like pure research, but we want our work to be something that can be tested by everyday use while participating in the media of architecture and design. We want to be part of a bigger discussion. We like academia, but we don't want the work to be meaningful only for an audience in the ivory tower." So if Ball Nogues is actively trying to break apart the notion of the architectural laboratory, is there any reason as to why it should remain? If you asked architect Eyal Weizman, the answer would be no, or rather that it cannot. For his recent book, Forensic Architecture, Wiseman notes how forensics, the science of forensics, operates on three sites, the field, the form, and finally, the laboratory, which he equates with his own studio. Yet Wiseman is careful to note how the laboratory analogy simply cannot hold anymore. Quote, the laboratory itself gets diffused when stages of investigative work, the exposure, documentation, collation, validation, and analysis of evidence using satellite images like these or video analysis is crowdsourced. In this context, the classic terms of verification, expertise, provenance, and the chain of custody are replaced by the multiple checks on truth and accuracy provided by the crowd, right? So when the laboratory moves to the world at large, public participation kind of devalues it, right? It doesn't become a laboratory anymore. And this is a strange place to end, for I began with a claim that at least in the domains of architectural practice and education, the space of the laboratory model moved from its interior confines to the world outside, to the world at large. Yet, as Benjamin Ball and I.L. Wiseman's observations suggest, it is precisely when the laboratory moves out to the world that it simply loses its ability to capture the dimensions of contemporary practice. I wonder, then, if architecture's role is to subject the laboratory to a laboratory, a meta-operation, which you see right here now in this setting in this beautiful venue. Because it is through curated practices like these that the importance of the laboratory can be communicated to future audiences. Thank you.
Thank you both so much. I'm kind of reeling. For such a thorough kind of history of the concept, and also for what I feel like was a forensic operation, like we just toured the lab where Frankenstein left out the window, and we're trying to figure out like where did he go. Right. So yeah, that was great. Before we open it up to the audience, I had a couple of questions that I wanted to ask you, and I guess the first one was this function of the lab and the studio, this term that kept coming up in many of your points, and even I thought it was interesting in Wigley's statement that you quoted. He doesn't use the word lab. And in the naming of the network was Studio X, individual ones are often called labs. So it's this kind of slipperiness that I think is interesting. So in the sense of the difference between what emerges from a lab as an architectural idea versus what emerges from a studio, how would you give the definition of the special character that the lab gives to an idea or to a project?
Me?
I just talked a long time. You can talk.
It's a fact that I was surprised at the beginning that Mark Wigley did not refer to he didn't call it Lab X, for example, he called it Studio X, which is quite surprising. It remains the fact that when they talk about them on the website, when they describe them, they do refer to them as laboratories, not in the text in itself, that I agree with you.
Because I think it seems like sometimes it's very important to
Yes.
say there's a difference.
Mm-hmm.
That's the whole claim.
Mm-hmm.
And other times it doesn't seem to matter.
I think it matters all the time. I mean, there's if you look at the diagram that I presented with the three poles, the tripolar diagram, there's a level 0 that I did not mention here, which would be just the naming of the laboratory. The fact that somebody chooses to name something a laboratory in architecture in itself is a statement. I mean, it means that they're trying to do something different. We don't know what it is. It could be completely empty. The way Studio X is, it's right like a box, like a frame, and anything could happen in it. And actually, when they discussed the question of the Studio X's, they asked a director at one point, the director of Rio. They said, "What's your lab's going to be like?" It's going to be an empty room with a coffee machine. That's what it's all about. So it is a label before being anything else, I think. And the more precise they become, like Kiesler's, for example, where they have instruments, you have machines, you have a method, you have a exchanges of information, you have experts coming in, going out, etc. Then you get something that's more built, more solid, but it doesn't take anything from the fact that if you just state that you have a laboratory, it's already a way of positioning yourself in this field. And compared to the others, it's not a studio in a way. You're basically breaking with tradition, right? But just by doing it.
I think so the question was to reframe the question again, because I was going to.
What defines the product?
The product of the
versus the studio, yeah. What character does it give?
You're right. I think I guess my way of answering that is through another question, because or it's through an observation, because I wonder if this is all, when we look at the artifacts that we see in the exhibit and some of the stuff that you saw in the presentations, there's the underlying assumption is there's something that's scientific about architecture, right? So we were talking about removing things, right? About taking things out earlier today out of the equation. So what if we remove the kind of scientific, kind of aspirations of architecture and treat it as a purely kind of aesthetic, to get away from the techniques focused on aesthetics? It's then does the laboratory method still hold? That's a question.
But it's a fact that the first laboratories, at least, the more solid ones, I'm trying to compare them, do rely on a specific scientific approach. It's a fact. Mm-hmm. So the way I made a distinction between architectural objects, which are usually produced in studios, maybe artistic way, and knowledge, which is built in scientific ways in laboratories. Because in science, you don't build, again, I go back to this, you don't build medicine, actual medicine in laboratories. You develop the formulas, you develop the knowledge in order to produce those things. And those things are produced by the industry. So usually laboratories don't produce things, they produce knowledge. Mm-hmm. And in architecture, it's a bit weird because we have this tendency to try to produce things. We want to produce things. And that brings us all to back to something I didn't discuss today, which was the approach to experimentation. Experimentation can be seen as a process, a scientific process. It's also an experimental stance, an artistic stance of being experimental. And both can be found in a laboratory. So you can produce things that are experimental, but you can produce them through experimental processes, which are more scientific. So architecture is a bit of a weird discipline because we have a foot in each, right? A bit of science, a bit of art, and we don't really know how to define it, but the laboratory doesn't define things. It kind of puts everything in relationship and just goes on with it.
I also wonder if if one of the products of the laboratory, putting architecture back in the picture, one of the products is just rhetoric. It's this is what we do, and we're gonna use the laboratory metaphor. And the thing is that brings up the thorny issue whether the architectural laboratory is scientific or it's scientistic, mm-hmm. right? Whether it just kind of takes on the vestments of science in order to legitimize itself. The thing is I view both as valid, and just one is not better than the other. And it's I think both have their roles, both have had their roles in history, and both have their roles now, and both will continue to have the roles in the future. However, though, what I'm really curious about, and this is what we were talking about, is their disappearance. Because we were talking about how it's you can talk about the disappearance of the labs at Columbia is there's a new person at the helm, mm-hmm. But is it more than that? And I just, I guess I'm asking you to speculate a little bit what you may think, why the reason that is.
I don't think they're disappearing. I was just, looking at this in a very surprised way when I noticed that they were disappearing from the website.
Oh,
that's
from the
for
website,
sure.
yeah.
That's the thing. But again, going back to the idea of the laboratory as mirror, as the laboratory as blueprint, The main thing about the laboratory is it's about research. And the way I see it is the importance of the laboratory in architecture today is because we have more research today than we had in the past. And a studio does not rely on research as much as an artistic expression through a project. And maybe that goes back to your first question. The idea that the results of the laboratory are more based on research, maybe with an artistic approach, but still research somehow. And that's not going away. I think research is everywhere right now. And information is more important than the object. I think that's, if I may, I'm just going to go into something else. What really started the thesis actually was not, wasn't the laboratory itself. It started with gastronomy. And this idea of, it started with what Ferran Adrià does at El Bulli, which was really surprising. He was on top of the world. He was doing research and at the same time producing, meals and dishes were quite special, experimental. And at the top of his success, he decided to close and turn his restaurant. It made so much sense for me, right? But he decided to close his restaurant to turn it into a research center, because it was more important to produce information and new ways of cooking instead of just producing meals and feeding people expensive meals.
I was going to say, this is a sort of a wonderfully privileged position to be able to
Absolutely.
be able to close your shop and go to pure research. But there was, it's a very good point. There was an interesting, in your diagram earlier, showing the kind of incredible growth of the lab. I was surprised that there wasn't a sort of a cyclical function. Like, it didn't seem to relate to, I don't know, economic crashes or these other things that normally affect certain trends in architecture, right? There wasn't like no one was building, and so everyone went to found a lab or work in a lab. So I thought that was kind of curious, and it made me wonder, and recently there's been some interesting writing on the kind of turn away from history theory in architectural practice, and I wonder, is the lab starting to do kind of a function like that, of being a place where you reflect on practice?
I think it's related to the issue of expertise, because maybe what's a concurrent trend with this explosion with this is like just this explosion of specialization, which is, you can think of something that's kind of like born out of a laboratory. It's like you create a specific type of architectural expertise through a particular kind of studio, answering very specific questions, right? So when I was studying, working on my doctorate, there was one of the visiting crew for studio was worked for Front. Basically, the entire studio was about facade technology, and then also just like in studios you have like integrated studios, you have studios that try to focus on mechanical systems and stuff. So it's like but then again, it's like, is that expertise, or is that kind of like the vestment of expertise? And like one wonders if the rise of the global network, the Studio X, if that was first of all a response to partly because it started a little bit before, but as it grew, it was a response to the recession. The firms were downsizing. That's what happens when you work in a field that's like capital intensive, right? It's like people run out of money, you can't work. And I wonder that paired with the kind of specialization that's kind of seen like in American academia and history and theory. It's like those affiliated with design culture are like, we don't want none of that. We want to focus like on this very specific architectural problem, and we think we can solve it. We can deal with it without reading whoever, So. It's an interesting question. It puts me at an impasse, because after I got my doctorate, I was a project manager for a large research study where I managed four teams of designers, and it was kind of like I felt like the combat reporter, it was kind of like, or the embedded reporter. I felt like as this kind of like historian, managing this like group. These groups of of landscape architects and architects for designing coastal resilience schemes, it was like kind of like, oh, I'm not sure how to talk to you, but let me talk to you about 18th century French engineering, because that's what I know. And they're kind of like, no, no. And also, so our client was the U.S. Army Corps of Engineers, and it's like, I told them, oh, it's interesting because your engineering principles are based out of French as opposed to British engineering principles, and they're like, is it 5 o'clock yet? Because we have to. We're government employees. We work on a clock. It's like, but no, it's really. It's just like colliding. It's like colliding and repelling spheres of specialization when we talk about design versus history theory. That sounds like a what's the word, news bit, whatever. Headline, yeah. Lead, yeah.